bonjour, hello, hello. So I will do the presentation in English, but you can also ask me in French. And I'm happy to start here, and I'm also happy to work more on my French and to get more fluent and to get all the words again. And then I will do the next time in 2 years. I'll do the presentation in French. Okay, so agenda. I will give a brief background about me, tell you something about the projects I was working on, tell you the main part about research here, and also tell you something about teaching, because I'm also doing a lot of stuff in that direction. Whenever you have questions, you can just interrupt me right in that point, and I can warn you already, so I have a bunch of slides. I will go through some of them quite fast. They are more like when you have questions to that, then we can stop there, and let's get started. So yeah, about me. So I have 2 brothers here, and I'm the oldest boy, and this is my wife. And I also do hobbies, so I like doing swimming, I like doing sports. So this is at Munich at the university, we have nice sports. And I also like doing photos. And so at some parts in the presentation, I also put some photos. This is then always, okay, part ends, and then we can rest a bit, and then we can continue. I studied computer science with an emphasis on computer graphics and media science in Tübingen in Germany. Then I have a PhD from Technical University of Munich. And there, at the moment, I'm still leading the IoT Smart Space team and finishing my habilitation at the moment. And I am also in the Académie Franco-Allemande, German-French Academy. So who heard of the German-French Academy already? Okay, not everybody. That means we do not do enough publicity yet. So the German-French Academy is a special ensemble of IMT and TUM. And the idea there is to foster the exchange between France and Germany, and so I'm a good example for that, so that it worked. And so there we have, on the one hand, we have research projects. So with several people here in the room, I'm also in research projects. So I'm in the Shive project with Nicolas and Jean-Marie and Yorgos, and yeah. And we also support teaching activities. So we did a summer school last year with the Atlantique now, where I also got to know several of the people here in the room. We're planning to do a 2nd edition this year, and we are also doing a big deal, which is massive open online courses. And so there we are currently supporting 2 massive open online courses. So one is of Gérard Memmi and Georg Kahle, and they do together a blockchain MOOC. And the other one is about Industrial Internet of Things Essentials that Nicolas and I are doing together with Yorgos, Alexandre Baptiste, and so on. And also Laurent, of course. And yeah, in September, October, I will also start here. Then I'm really looking forward to that, and being then really here and not having to travel for 12 hours from Munich here. Okay, so Munich, you probably all know where it is. If you get the chance to go there, it's always nice. You have the Oktoberfest, you have the beer, and so on. And yeah, these are the stations where I was. In Tübingen, you have a famous boat race. When you get to the computer science department in Munich, in Germany, all computer science or all public buildings have to spend 3% of their budget for art, and the computer science department puts some large slides that you can actually slide in, so that's very nice. And this is close to here. This is at Mont Saint-Michel, and this is me and the team last year. Okay, so I have basically 2 research streams. This is secure and autonomous management of Internet of Things with a focus on security here, and also digital teaching, and I will come more to this. I have also a strong bond with France, so I was spending my academic career so far in Germany, but I always had projects here and summer schools and so on. And most important, on the way here, I earned my most prestigious diploma. Then I got a diploma for going with 300 kilometers per hour with the TGV. So I was very impressed when I saw that on my tab that I just wanted to close, that there was this information. Okay, that brings me now to the research projects. Yeah, so I was involved in different European Union projects, and also German-French Academy, and also German-Finnish collaborations in different roles and different leading roles there. So the most recent project is a project about sharing energy in smart neighborhoods. So this is about when you produce renewable energy or you have storage installed in your house, how can you share this with your neighboring houses? So this can be industrial spaces, this can also like residential spaces or commercial spaces. And the idea there is to enable an ICT solution that allows you to install, for instance, a bigger battery storage so that your neighbors can pay you for having this storage installed. And for this project, we use blockchain technology and we use artificial intelligence to do predictions on usage. And blockchain, we use it for logging of exchange of energy and also of control commands, because we also want to do predictive orchestration in these different spaces in this project. Yeah, so this is quite an interesting project. This is the team here. Yeah, I wrote it again. So it's the AI for the forecast and the automated pricing. And the idea is that here we have then a self-organizing system of the households and then the energy is exchanged. And in the project, we have also partners for the technical side, of course. And the interesting thing here is the cross-commodity. That means we do not want only to exchange electricity as you have it today, but we also want to exchange heat or cooling between the different buildings. And this brings then synergies that are not there at the moment. An interesting aspect of this project is also that we also have a look at the legal perspective. We don't have lawyers in the project, besides from the project partners, from the industrial ones that of course have the lawyers, because such solutions are neither in Germany nor in the Finnish side at the moment fully covered by the legal frame, and therefore we also give recommendations for the policymakers in that direction. Okay, then another project is the Smart Cyber Physical Environments for Industry of the Future. So so there we are looking at industrial control systems and how we can optimize something there. And we had a nice demo where Jeff was also heavily involved last year. And so one application that we look at there is we have some industrial robots here that are transporting some goods. And the idea in this demo is that most often, or in the future, you may not have all robots fully equipped with all sensors. And therefore what we did here, we did a kind of remote sensing plus sensor fusion. That means we had two intelligent robots here that have some LiDAR sensors that can know where the others are. And these here are just dump robots that are just following the line here. And then those were sending the information back to a central control backend in the cloud. And then there was a live decision if these robots had to stop or not. And so this is also what we see here on the right. So this robot can just look to the front, so it could not see the other robot before it really crossed the line, but it's still already stopped. And this only happened because we had the intelligence in the back end. And one challenge here is, of course, latency, and we also have other partners that take care of failovers so that we can use software-defined networking to switch the network in the back end so that this is working. Okay, then there are several security-related projects together with different partners. This is about sending information to a trusted backend and doing then security decisions there. This is a European Union project where it was about smart charging infrastructure, so how you can direct cars through a country so that they always find a charger, but that they can also be used as a flexibility, so that they can transport energy from a point A to a point B. Then this was a project about how you can modularize the software infrastructure in a building, and this was a predecessor of this project where we already started at using knowledge also for orchestrating environments. Okay, good. And then I also acquired a substantial amount of teaching funding for different teaching formats, more to that in the end. I work together with people all over the world for the different projects here. Maybe one other interesting aspect, I was also one of the 4 main proposal creators for a research center for internet research that was founded in Munich, because there was, I think 2 years ago in Germany, a concours about creating a German internet institute, and so we were one of the candidates there. And there I was also heavily involved. Okay, good. Then, here's just some people listed. And that brings us to the end of this first part. And this is a nice picture because this is actually when I finally submitted the application to IMT because I was in the US and I was cutting some trees at my brother's site, and we were sending this via mobile phone. And this is actually here the computer. I was just pressing send the email, and then I was continuing the cutting. Okay, good. That brings me then to the main part, namely the research. Okay, so the research, when I started with this research line in 2008, I came from computer graphics, and I always wanted to do some research that is something where I can show the people, okay, this is what I'm doing. So I wanted to have something that is applicable and something that I also consider highly relevant. And what happened there in 2008? Well, these smartphones here emerged, and most important, the app economy for the smartphones emerged. And this is something very fascinating because it unlocked a huge creative potential with the people that started developing apps for these phones here. And so if all these people would start studying computer science, then there would probably be enough computer scientists on the market. So nice thing, this started. And then I thought, okay, the smartphone is a little bit, is nice, but it still has the problem that everything happens within the shell of the smartphone. So everything is in here. Of course, you can also connect some sensors and actuators to the outside, but still you're somehow limited to this phone. And then I thought, okay, it would be cool if we could do this with actual physical spaces. So if I could enable people to write programs that are running then in rooms like this room here, so that they can then program this. And then I started looking at enablers. So what do I have to do there? And the key enabler for that, of course, is security. Because when you look at the physical space, you have lots of security implications. So on the one hand, when you think about an industrial production site, for instance, that uses software control, because this is exactly the shift here, that we went from hardware control to having something flexible because it's controlled by software. And when you do the same with the physical space here, then you can consider in a car manufacturing case, for instance, that you have a very heavy robot arm, and if the software has an error, then this robot arm can easily kill someone. Okay, so this is a drastic problem when there's not enough security, which has the safety implications then, of course. On the other side, there's also lots of data that is getting collected, and it's maybe not directly harming you, but still it's harming you because in the best case you get targeted advertisement. In the worst case, someone exactly knows your habits and knows when you're at home and then can go into your home and steal some stuff or other things about you. Okay, so these are of course challenges, but the cool thing is if we can program the environment, if it works, so if you have a nice abstraction to do that, then we are a little bit like a wizard, because then we can do something. The wizard is telling a spell and then something is happening, and as computer scientists, our spell is the computer program. And if we have the runtime environment where we can run the computer program, then we can throw the spell into the room here, it's executed, and then we have some fancy disco lighting here, for instance. So this would be then one magic thing that is happening in the physical environment. Okay. Environments, of course, of all kinds, so these can be factories, public spaces, or homes. So when you do research in this area, the nice thing is that it's at the intersection of different research fields that are established in the past. The bad thing about doing research in this area is that it's in the intersection of different research areas that emerged in the past, because the problem is a little bit, when you're here in the center, you always have overlap with another area, and in the research, at the moment we are still somehow siloed, meaning when I want to publish something in the cyber-physical systems area, then they are not so much interested into ambient computing, even though for me it's highly connected, and this makes it sometimes a little bit difficult to publish in this thing. But therefore what I did when I started, I went to the UbiComp and PerComp communities, so they're more application-centric, and then afterwards I moved to the network management community here, because they have a more systematic approach on doing structured management of entities. And so therefore this fit more to me, even though I still have the use cases from here. And so I'm very heavily active in these communities here, and I try to push them a little bit more towards, okay, Internet of Things is also about use cases, and it's not only about managing mobile operator equipment like eNodeBs or something like that. And they slowly move a little bit. So I'm like the water drop that is trying to put something into the stone there. Okay, the good thing is, in the recent past, also the major networking communities, conference events here, they started moving into this direction. So there were some few publications that go into the direction of what I'm describing here in the past years, which is a good thing, because I consider this really a key area for computer science to do something here, and also to break these silos and have some collaboration here using the tools from different areas and also the research tools and methodologies that I use there. Okay, so when you look at the research, then it looks a little bit like this star sign here. It started all in 2008 with some middleware analysis. And then when you do this, when you look at, okay, how can these spaces be orchestrated, what do the people do there? Well, they do mainly two things. So they implement workflows, obviously. And the second thing is they have to connect hardware devices, because the hardware devices are heterogeneous. So you don't have the standard communication protocol for IoT devices. And you will also never have it, I would say, because there are technical implications that require different protocols. So if you have a wireless battery-powered sensor, it will use a different communication protocol and behavior than when you have a fully continuously powered entity in your system. Okay, so when you look at this, you see challenges, usability, and complexity, and also reusability, which goes in line also with the complexity here. Because if you can reuse components, when you think about an object-oriented modular architecture, reusing existing components makes the system more resilient because the components are hopefully tested, plus it makes it much faster for you to develop things. So modularization is one of the keys here, and providing connectivity is one of the major challenges. And also how to discover something then in here, and of course how to provide security. Okay, then from there, I went to, okay, when I want to provide this, what is the thing that is in common between these two here? Well, you have to exchange data, as you have to do with all computer processes. So you have some data, then you run an algorithm, and then you have some other data. So you change something with the data there. And therefore, I started developing a data-centric middleware that is self-organizing, more to that in a minute, and that provides two functionalities, mainly data management here, obviously, and also service management. For the data management, as it's more novel, the focus here is on semantics. So it's not only about data exchange, but it's about exchanging semantic data, so data that is tagged. And this is very helpful because when you want to do research in this area, you always need to have some context. So you need to have some tagged data. And with this thing here, we always have tagged data. Yes?
Sorry to interrupt. Just to follow what is modularization? I don't absolutely know anything. Can you just resume and
yes. Sure, yeah, very good question. And really just interrupt me when there's something unclear. So with modularization, I mean that when before you implemented a control for this room here, for instance, what you did is you created a monolithic software. So it was just one process that was running. And what I try to do now is to tear that apart into microservices that you compose dynamically so that you can reuse the different components for implementing different workflows. And it has two major advantages. So one is that it gets easier because you can reuse existing and tested components. And the second major advantage is that you can do time sharing in the environment here. Because when you have the monolithic thing, then you're hardwired in the software sense that you have the addresses, and you have then usually only you access the devices at that time. And in the other case, when you have the dynamic binding of the microservices, then you can say, okay, I now need to control the lights, but later I don't have to and someone else can do so. Okay, good. So semantics, so more to that also in a minute, and strong modularization here within services. So taking a monolithic software and tearing it apart into smaller microservices that can be composed ad hoc at runtime to implement use cases. The service management I did not detail But there are, of course, the usual things for service management. So this is about service placement and service migration at runtime, so that you optimize where the services are running. Okay. Then, the good thing is, when you have a middleware that is managing the connectivity, discoverability, and also the data exchange, and also the data, then you can implement certain of the wanted features by design. Because we'll see also this more in detail. In our case, it's now that the software developer is creating the algorithm, but the data is managed by the middleware. And as the data is a critical thing regarding security issues and also scalability and so on issues, the good thing is when you control the component that has the critical data in this case, then you can implement this by design. You can enforce it by design, meaning that a developer cannot destroy it. So it's always there because it's part of the system that the developer of the software component is only using and cannot destroy the properties there. Relevant properties are security, dependability, scalability, usability, and also quality of service. Okay, so this just as a roadmap and overview now, bringing us to the next picture. So this is a museum in Munich. And from there, we go now a step back again to the standard orchestration. So you remember, you have implementation of the workflows and connectivity to devices. And so this is exactly what we see here. So the connectivity to the devices is, IoT devices are cyber physical devices, so they connect the cyber with the physicality, meaning, among other properties, that you have physical phenomena here, they are sensed or changed, so sensors and actuators here, and they offer you a software interface for remote control. Or better, remote management, because they allow you to monitor and control, which together is management. So you can read out data from there and you can change something to there. And then when you want to implement some workflows, you typically have a software, then you have a user interface often, and then you have users that express something that they want to do with the software. When you look at this stack, as I told you before, you can find out, okay, so when we are looking at the computer science part of this, then it's mainly here, maybe going a little bit also to here. The center in this picture is then the communication and the data management here. And this is why we made this explicit. Okay, now I will use the same colors, but I will connect the planes here, because this shows already how you can reduce the complexity. And so here we see again the real world and the hardware here that we have. And then as next thing, you have then the software services here that offer the functionality as before. And in the middle, you have the data management. The good thing now in this picture is that you can unfold this half circles here, and then you only have 1, 2, 3 layers here. So it was reduced by these layers here. Because then your understanding is just, you have software that interfaces devices, and the devices can then either communicate with humans or with the physical environment, which is conceptually the same. That also means, when you unfold it now, that the northbound interface of these services here can be standardized, because it can be then this thing that the middleware here uses, while the southbound interface will still be the one that has to be adapted to the different devices that you want to connect there. Okay. Good. The communication relationship is then, as this component here is providing the communication between the software artifacts, so that the software artifacts connect to the middleware here and do not talk to each other. And this is very helpful when you implement these features by design, because then everything has to go through your component. At the same time, it's of course challenging, because it means that your component has to offer everything that the people need to connect services, from the communication primitives up to the quality of service that you need for the different communication channels that you have between there, to the semantics that you need to express things here. Okay, let's jump back to this one. Well, we have now the different layers here, and then when you want to implement use cases, Then these are of course vertical because they involve all the different layers. When you look from a security perspective, so you can destroy everything in all of the layers. So I already named examples for that. And when you come now from where can I do something as a researcher, my answer is okay. You can look at the services and the apps, of course, and you can look at the data, and you can look at a certain extent at the hardware that we have there. And this is exactly what we do so far. So we have a data-centric service coupling platform. So this is service management. Then we have the service management on the nodes, and we have the semantically rich communication, which is about the data here. And what I like to say is that using this middleware is not solving all the issues maybe that the IoT has, and it will probably never be adopted by a large amount of players. I mean, I would be happy if it would. But the nice thing is, by having such a concept here, that it enables you to directly look at the problems, because it solves all the issues that you normally have to solve around the problems about security and so on. And this makes it much faster to do research in this direction. It also makes it challenging to communicate, because it's still not enough known, and so you first have to explain to people why this is solving major problems that you normally have there. Okay. And so it enables rapid prototyping of relevant scenarios, and therefore it's perfect for collaboration. And so this is also one of the major assets, because I would love to collaborate with all of you, of course, then, where we could look at, okay, if you also have some use cases, some research you want to do, where we could use this technology in order to make real big progress on the research side here. Okay, good. Lissabon. Research directions. As said at the beginning, so there are these 3 research lines. So there's this middleware for the data management and connectivity, service management, and also research and education. That is also in line with these here. As verticals, there's security, dependability, scalability, usability. And this is of course not driven in the theoretical side, but as I said, I want to always practically apply it. And therefore we have different use cases here where things are happening. Also industrial IoT and also smart vehicles is also a very good example, because there you have also sensors. In addition to the other scenarios, they're even more mobile and more ad hoc in what they do. Central basic concepts. So distributed systems are complex, and therefore it's helpful to separate logic and data. So the algorithm and the data that is exchanged. Then managing the key asset on the software side in the systems that we control. So having autonomous data management, providing structure and providing means for discovery, and modularity, enabling mashups, and then requiring, of course, autonomous service management. When you have microservices floating around and you have to put them together ad hoc, then you need an autonomous management that does that. And of course, security, it's essential, but it's complex, and therefore, again, if you can automate it, if you can provide things by design, this is the only way you can do it. This is also why I always say security, even though no one might want to pay for that at the beginning, because it is not a feature that the people directly see, it's something that we cannot introduce later to a system. So we have to have it in from the beginning. And this is also why this is so important to look at security for these distributed cyber-physical systems at the moment, because there is still not the industry standard that is solving everything, where they might have forgotten this security feature. Because if we have that, then, as we already see in several of the security exploits, then this is really a major issue. Just thinking about the connected cars, for instance, when then the autonomous driving is relying on the back end and you don't have connectivity. Okay, so these are the PhD students, so just briefly, so they are collaborating and working on these topics. Assessing the research, testbeds, pilots, co-simulation, user studies, these are the typical tools that we were using so far. Okay, now coming to the middleware. So here are some papers if you're interested. So probably we can distribute the slides afterwards also. This is the middleware, so a little bit more in detail. So as I told you, it's a self-managing peer-to-peer system. So we have nodes. they're automatically finding each other. They're using at the moment IP for connectivity. They could also use something else. And then they're automatically creating the overlay, and from that point in time, software services on each of the compute nodes here can connect to this abstraction, and then they get transparent access to all the other nodes here. I will show you in a minute how nice this works then. Okay, data is the central element. Therefore, this system implements a modular ontology. So a modular system, how you can express the properties of the physical world on the software side. A little bit in detail, so we have here the object-oriented concept. So you can define, for instance, that this is a thermostat that controls a room temperature, and then it can have certain properties, and you can inherit from that, and then you can create more complex structures. And from a programming language design point of view, this can be compared to polymorphic interfaces, meaning that when you include this model in your data, someone else can discover it no matter on which level of nesting in this tree here it's stored. More details when you're using it, then you see easily how this works. Now, here's a good example. So we have now different services that interface the devices that we have here. And this middleware now spans a tree, and the nodes of the tree, they represent the properties of the physical entities that are controlled here. Okay. And they connect to each other, and then you can do something in between. So with this, we implemented a game here, where it took about 1 day to implement this, so it really went fast. And so here we have a sensor, and then it's getting triggered, and you have to remove your hand, and then you can win and lose. And so this is also something that we'll do at the summer school with the students there. When you want to implement such a game, on the right side here you see a pseudocode, and so here it says, for instance, wait for some properties fulfilled, and then get something. And this can be directly mapped to our abstraction, because now we can access data properties, so we can directly implement these rules here. So we want to get the lux value of the box 2 here, and we want to get the luminosity of the box 1 here. So we just give the address, and then it's automatically retrieving it. And it's modular because this one here is just asking the KA here, it's asking automatically this one transparent to the other, it's asking the software that is interfacing it, and it's retrieving the value and going back the chain here. It's very comfortable to do that. Then you have your algorithm here, so here you have to implement something, and then you get the times here. And with the setting you can do exactly the same. And what's happening here is that these components are all autonomous, and that means when you change something in the model, it tries to reflect it to the physical world that is around there. Okay. Good. Another picture. Vostok. Service management. So this only brief. So there we look at the entire life cycle of the service. The idea here is to have something similar to the app economy. So we have a central store where you can put your software, and from there it's getting distributed to the different sites. We have different developers, different sites here, and look at everything from development, distribution, configuration, dependency, deployment, up to update and security management, of course. Here we see again the different sites. We see the management components in here that do the autonomous software management, and this is the third view, and the middleware is used here for communication, also for the software management. So this is also very nice because we can use our own infrastructure here to do the distribution and management of the software within an IoT site. Okay. Saint-Malo. And now we come to the security side. And a guiding example here is an autonomous car. And in the autonomous car, you collect some data, you process it locally, so until this point everything is fine. And once it leaves this boundary of your local car, then it becomes interesting. Because then suddenly the data that is collected here is not in your hand anymore. So someone else has the data and can then give the data to someone else, which could be the police, which could be good or bad, but it could also be advertisement companies or some hackers that got access to the data. And then this becomes problematic here. So this is why you have to have security by design only giving that information that you're okay with getting distributed there. An example why this is interesting from China, because in China you can see very well how it might develop also in Europe. So this is an actual use case. So this is a truck driver or a bus driver. And what is happening here, they have cameras and they do with AI, they find out which is his face and what is his mood, what he's currently doing. And then when he tends to fall asleep, he gets a warning. Okay, that's fine. The bad thing is they are not evaluating this in the bus, but they are sending it to a backend. And so that means they have total mass surveillance of the bus driver. And this is just one example. In this talk where I took the slides from, and there are also more examples about that. Of course, you have good examples. I just switch over that. But you also have many bad use cases that you can do there. The message behind it is, first we have Facebook. In Facebook, people are entering information about you, and then Facebook knows something that some people entered. With the IoT, it becomes worse because we have many more sensors and they are neutral. So you can always say, okay, my friend wrote something wrong in Facebook, it's not me. But when the sensor measures, okay, you're waiting that much, or you're showering that often, or you're doing this and that, and this is stored in something similar like a Facebook, then you have a problem. And you don't have a problem when it's stored, but the problem comes with the artificial intelligence or the machine learning, because now we can use the data, we can do data mining and we can do data analytics, and then we can do something with the data. So again, example from China, so there you get, for instance, then better health insurance points. So this is something that they also discussed in Europe, but you get punishments if you don't behave like the state wants you to behave. So you maybe read in the news about it, that you're then not allowed to fly anymore when you're not behaving the way the state wants you to behave. And so this is possible through the ICT technology that we have there. And therefore, as developers and researchers, we have to be aware of the ethical dimension there as well. Okay, how many minutes do I have left? 0 minus 2?
11 heures. 11 heures, c'est ce qu'on avait dit, c'est 11h15. C'était 11h15.
I just continue.
Yeah, 3 minutes.
Okay. Okay.
If you want to have time for questions.
Yeah. No. So far, I wanted to show you three more things for the security. So the first thing is we want to prevent incidents, and therefore we need identities, secure metadata, and access control. And this is again nice when you have such a system, because what you can do there is when you control the data, you can also enforce the access control in different ways, with policies or with just static rules that you have group-based access control, for instance. So this is a nice thing you can do here. Next thing is we can do anomaly detection. So this moves now more towards the applications, because what we can do when we control the communication, plus we have the metadata of the communication, so the context information, so it's a rich data that we can look at there. We can observe services and have the black box assumption. We don't know what the developer put into the service, but we just observe what the communication is. Then we do the passive traffic monitoring, and then we can do behavior modeling. So how does this service behave in its communication behavior? And when we have that, we can do anomaly detection, because then we can say, we assume we learned now how the service should normally behave, and if it behaves differently, then we can say, okay, we block this, or we at least warn the user. And so this is, I consider, a very promising approach, because you will always have the black boxes. Think about some firmwares that are on some devices that you bought over the internet. You will most likely not get the source code, and also no certificate that the code is doing what you expect it to do. This is an example where we looked at it. So in this demo, we made the washing machine open the front door of the building to illustrate what can happen there. Interesting information here is that we do not only do the observations within one site, but we share this information between different IoT sites, which helps us, of course, to improve the models there. One aspect we look at is periodicities, and here you see nicely why having the context or the semantically rich data helps, because we do not only see this here, but we can decompose this into distinct traffic flows in here, and in the distinct traffic flows we can indeed detect periodicities, and this is then an important part of the model here. And this is also something I want to continue looking at. How can we do this automated modeling and make use of that? On the other side, there's also now works on that the people creating devices are providing readable descriptions of what their software and their hardware are doing. This is also nice. This is a complementary approach, but you will still probably never have it for all the devices. So this is why this is still very important. As said, this is then coming from here, access control, to the software side here. So we are looking at the services. And then the third is when we want to move even further to the hardware side, we can introduce some watermarking, meaning when you think about a production process, for instance, and someone does an advanced persistent threat, so some attack that is not really noticeable easily, so just changing small parameters here. What we want to do here is that we have some watermarking signals, and when someone changes some parameters just slightly, these watermarking signals are changing drastically, so that you can see, okay, there was a small change, but it might have a big effect. And this might not only be an attack, but it could also be a bearing of a device, for instance, so that the quality is just not good enough and it has to be replaced. Okay, good. Lots of publications if you're interested, and also IoT is still on the hype cycle of Carnac coming down here, so it's still very important to do something there. Okay. Yeah, research community. This one I said already, so metadata available, low latency communication is an important aspect, machine learning based prediction, automated updates, automated modeling of service behaviors, policy based access control, cloud based recommender system for security parameters, because the user is always also an important factor when it comes to security, privacy protection, fault identification, and watermarking. So these are research topics in the security area that I am so far working on, and I would also love to continue working on with some of you. Okay, so this was last year, and Mont Saint-Michel, of course, Ad Hoc Now conference, and yeah, let's briefly sum up now. So I'm also active in the community, as I said, so mainly in the network management so far, and then teaching, so there you also know some of the faces here. It's a little bit dark. This was the summer school last year, and yeah, I was doing lots of teaching already during my own studies. Also did all the major formats there. A key thing is I'm also doing a massive open online course right now, so moving from the presence learning more to the distant learning scenario. And so this is also what I do in the Académie Franco-Allemande at the moment. Several teaching prizes, had lots of students, more than 80 master and bachelor students so far, and more than 2,000 students that I was teaching how the internet works in my lab courses. I'm also running the biggest teaching course about how the internet works, at least in Germany, since 2003. That is also running at 3 universities now, so 2 in Munich, 2 in Germany, and 1 also in Australia. And now this online course part here, people do not only learn the internet here, but also some soft skills, some additional ones that I consider highly important, special methodology for that. This is how it looks like when the people are doing the exercise. And yeah, this is the last thing now. So on the 24th, so this Monday, the online course on how the internet works started. And this is an important work for me because I consider the internet the backbone of the digital transformation. So this thing that is currently changing the entire life of everybody, and therefore I consider it important that the people know how this internet works. And therefore we created for the past 3 years, so we worked really long on this, a course where a more or less general audience with a little technical background can learn how the internet works. And so I will also, the link will be sent around also soon, also over the Académie Franco-Allemande. And so I highly encourage you to disseminate it to your friends, because I consider this really important knowledge for everybody in today's society to have at least a background in how this could work. Okay, so this is how an online course works. A special thing that we created there is a virtual learning environment here where the people can then configure their own internet. So it's not only teaching, but it's always combined with hands-on, because I consider this the best learning when you also apply the learned things directly afterwards. Okay, also I also have a YouTube channel with lots of interviews with people and so on. So this is also important science communication for me, and I'm also involved with the computer societies, with the ACM and so on. It is a German chapter there especially, and there we did last year a symposium where it was exactly about the effects of the digital transformation. And there was, for instance, Windsurf here, or Whitfield Diffie, the one from the Diffie-Hellman-Key exchange. Windsurf, one of the two original creators of the internet, together with Bob Kahn. Here's Robert Tyjan, he got the Turing Award for Algorithms, and there were more of those. So very interesting people that I was in contact for this event. Okay, and this brings us to the end with the bird and the overview. Thank you very much for your attention, and I'm open to your questions.
Prendre 5 minutes pour les questions si vous en avez. Sinon, bah, de toute façon, Marc-Olivier sera là avec nous pour les 2 jours. Et
Oui.
mieux que ça, il sera avec nous pour les futures années aussi.
Oui, c'est ça. And so the idea was really to give you now a little bit of portfolio that you know what I already have. I mean, I could have even told you more, but this, I think, was giving a good overview so that you know where they are connecting points. And I think we can very well get in touch over the next days and then over the next months and years and tens of years to do fruitful collaboration there. Yes?
You never mentioned energy efficiency when I look at your criteria. Is it integrated in some other criteria, or is it's solved, so no problem at all?
Yeah, it's a good question. So personally, I think the energy efficiency is important, of course, when you have wireless devices, because then you have batteries and you have to take care of that. So this is one aspect. And so there, for the research I'm doing there, I'm not caring too much about the energy efficiency for sensors, for instance, because the system is running in the back end, and the sensors you would connect via optimized protocols to this system I was looking at there. Regarding the overall energy consumption of such a system, this is also a very important point, because today, when you integrate ICT solutions for saving energy, often they use more energy than they could ever save. And for that aspect, I would say that hopefully with the renewable energy sources in the near future, we will have devices that are solar powered, and that means that the energy that they use will not be important because it's green energy.
Okay.
And so this is, so far I looked at it up to now. What we also have is we have a testbed, for instance, where we do energy measurements, of course, of what our middleware components use and so on, but we did not go into the optimization direction so far. Yeah. Other questions? All right.
Thank you very much.